and made up problems. They're there for a purpose of showing you something interesting. So if you bear with me, here's what's happening. I need you to know this great rule that if I say A over B plus C over D, remember fractions? And I have to take that, and if I want to get them to add, I actually have to have a common denominator. And one of the really easy ways to get a common denominator, if you didn't know, is actually to do multiply by the two denominators together. It's like b times d. So I would multiply the left one by d, but you always do it top and bottom. Because remember, that's equal to 1. It's really important that you do that. And on the other one, to make them have the same denominator, I'm going to multiply by b on the top and the bottom. Again, equal to 1. Because we're not changing the value of anything. We're just making it look different. So you get the idea that we're all about making things look different for the purpose of noticing something that you may not have noticed before. So all right, here you go. So you got AD. And on the bottom we got BD. This is the left one. Hope you're hanging in there with me. And then BC by, yeah, what? Go away. There we go. BC over BD. Done. Okay. Now, this trick is going to get used a lot, so those of you who decided to check out a second ago, make sure you're with me because this is important. This happens a lot. Kind of why the skills review is on there. There's crazy things like, so far we're just adding fractions, and when you have adding fractions, you have to have a common denominator. And it is easiest often for the common denominator to be the product of the two denominators. It just saves you a lot of thinking, so it's a little more mindless. I like that. Then what you do is you actually add them together. So we're not done yet. So what I have now is the top. And remember, adding fractions, it's numerator, oops, plus numerator, and over the common denominator. You don't add the denominators. You don't get b plus d, bd plus bd or anything like that, or 2bd. It's just bd. It's like 3/4 plus 2/4 is 5/4. You know, the denominator's common and it stays the same. Ta-da, that's it. So if I rewrite what I started with, way back in the beginning, a over b plus c over d is, ta-da, that thing. Well, there's a quicker way to it that I want to show you. And it'll be helpful to do this a little bit faster. And I think you'll get the idea. Do you kind of notice, since we're multiplying, the end result is we're going to have a denominator that's BD. Done. We have that part figured out. Easy peasy. The numerators are going to be, all you end up doing is multiplying each numerator, like the A gets multiplied by the D, the other denominator, and the C got multiplied by the B, the other denominator. So that ends up being my quick route. You take the opposite denominator times each numerator over the product of the denominators. So I'll write it in words because some people like words. Opposite. So opposite. This is a quick route because as they get messier and messier and messier and more complicated, this works every time, and it saves you the hang up on this looks hard. And you just go, I know how to add fractions, even the ugly ones, they're fine. So opposite denominator, meaning like, you'll know what I mean, times, great math term, each numerator. Now there's some other ways that we have to do this in other contexts, but this is one for two fractions. This is really a two-fraction method, the two-frac method. Two-frac math, both of which mean really interesting things on their own. Opposite denominator times each numerator over the product of the denominators. Are you running out of room? I'm getting there. Thankfully, this doesn't take up much space once you get it figured out. Okay, so imagine that you have more room in part A. You squeeze it off somewhere. B won't take any space at all now that we got this figured out. So I'm gonna move to where I have some clear space, and I'm gonna do A. And yeah, I think that'll work. Let's do that. A, if I do this method, I'm just gonna zoom way in there. Check this out. I'm simply gonna take the opposite denominator times each numerator. Now the thing that becomes important are parentheses. That's the big hang up. I'm going to add these fractions. So if your equation involves fractions, you are compelled to add them in 98% of the cases that we run into. This happens a lot in Calc 2. So we have a lot of these fractions. We learned a method in there that's called integration, partial fraction decomposition, integration by parts, and a few others that require us to add these fractions. And the last thing anybody wants to worry about, it's hard enough as it is how to add fractions. So we do this a lot. We'll say k minus 4 times the 3, k minus 3 times the 4 over the product of those two. So we'll just put them side by side. So I'm going to move to the bottom here. I'm going to forget what I had on here. I hope I have a sheet somewhere that I can remember this. K minus 3, k minus 4. I can do it. I can remember it. Okay. I just need more room. So this is what it'll look like. Remember, it was 3 times k minus 4. And on the bottom here, and then the other denominator ends up being 4 times k. I made it an x. But, all right, k minus 3. And then over the product of the denominators, and that's nothing fancy. It's just about parentheses. Use parentheses, use parentheses, use parentheses. Ta-da! Ladies and gentlemen, we just added a very crazy looking fraction right there. So I'm going to go, here's the original. I see that if I'm going to solve this, adding the fractions is going to be important. Man, that looks awful. Or it did now until today. K minus 4 times the 3, k minus 3 times the 4 over the product of the denominators. And this is what I get. Nice, huh? Only thing left to do, distribute and combine like terms. Old-fashioned algebra. The thing is, when you guys remember what was on the other side, if I go up there and take a look at it, this is where it becomes kind of a contrived problem. It's 25 over k squared minus 7k plus 12. I'm going to put that back because it's still there. Oh. Got it. Did I do it right?
Plus 12.
Oh no, I messed up. Thank you. 12. Got it. That's our whole expression. But the only thing that was new is that, hey, it's a fraction. You have to add them. And that's your habit. When you see fractions in an expression that you have to solve, or I'm sorry, an equation that you have to solve, it behooves you to add them together. This happens in trig. We're going to do this later on in trig, so it's good to have it now too, in addition to some other stuff we do. So distribute the 3, distribute the 4. Parentheses are uber important. Sometimes there's a minus sign in here, and you'd have to distribute a negative 4 or something like that. Keep an eye out for that stuff. So you got 3k, you got minus 12, you got plus 4k, minus 12. It's convenient. And on the bottom, I could distribute that. That'd be interesting. So it'd be k squared minus 4k minus 3k plus 12. And on the right-hand side, let's put this. I think I can copy and paste this thing here. Okay. I'm going to simplify a little bit more. Things that I can put together. Now, when you're solving this, I'm still eventually going to get to k, but right now I'm just doing the adding. I haven't finished the whole adding the two fractions yet. Combining like terms, all that kind of stuff. So I'm just working on it. Almost there. The 3k and 4k make 7k. Minus 12 and minus 12, if I did it all right, they just combine, right? So 7k minus 24. And on the bottom, we have k squared minus 7k plus 12. And I am going to rewrite the original now because it's important. This is where it's a contrived problem from teachers, with nothing better to do than contrive problems. Because they don't always work out this well, but we wanted it to. So this equation is, hey, solve this equation, which always means, hey, what are the k's that I could put in there that would work, that make both sides the same? Well, we're on our way. We have simply added the fractions on the left-hand side, and it took forever. And here it is. There it is on the left. I still have to find out what k is. And it looks awful and messy, and Does anyone want to do like cross multiplication and stuff? That's what I'm thinking. But there's another out. Usually we would cross multiply, crisscross applesauce, some of us call it. But it's even, do you guys see a shortcut to, is there anything you're noticing? Oh, we got options here. Hands fly. And yes, I'll get you through too. But.
I multiplied the k squared minus 7k plus 12 on the left side
Okay.
to the right side, and that would just cancel out the denominators. It would leave 7k minus 24.
Oh, you canceled the denominator. You see, multiply both sides by the denominator.
Yeah.
That's the one. You can multiply both sides by the.
I was just gonna say you can the numerators equal to each other since the denominators are the same.
Which also works. Oh, you guys are like, you set us up beautifully. Another option? See? The cool thing is both are right. If you have an equation like this, fractions, all you have to do is, if they have the same denominator already, you don't, if the thing to make them equal, what would make these the same is if their tops are the same because the bottoms are already the same. The numerators are the only thing we need to resolve. Like, what's the k that's going to make the tops 25 in both cases? Yeah, you just, and this is an eyeballer, so 7. Done. Because I know I need it to be 25 on top. That would be really reasonable and intelligent. The other option is multiply, but when you want to get rid of denominators, you multiply both sides by the denominator, which is actually more often than not what we end up doing is, because the denominators aren't the same, so you multiply both sides by denominators. Cool. You're both right. Happens that 3 of you right. This I want to point you towards, if you've never known, in these contrived problems where I made it so the denominators were the same, I want you to notice they have the same denominator. All you have to focus on is their numerators. So if that's new to you, cool. If not, then man, y'all are pretty slick. Those two are the only things we need to set equal because I just want to make sure they're the same on both sides. What k satisfies it? We already know it's 7, but we often, say, what if I couldn't do it by mentally thinking about it? Then you just set the two equal and find out what k is. And we do the old algebra, stuff like that. Oh, and write the right numbers. Then we get 7k equals 49, and we get k is 7. Oh, yeah, but we could have guessed that ages ago. Cool, huh? Then, so I'll pause here in a second. I want you to peek at an email. You guys get to see my emails as they come in. The next one, it goes faster now because you're experts and you know it's contrived. If you know you can work ahead, great, but I'm just going to take each denominator times the other numerator, so that, and use parentheses liberally. I mean, you got to have parentheses. You can't live without them. They are so important. Equals this thing. And on the denominator, so you other denominator times each other numerator. That's what the arrows I put up there are all about. Here's the result of it. Now, the denominator of the result is always just the product of the two. So it's just a shortcut to the long way that we all know and love. Okay. And then after simplifying that left-hand side, distributing all the necessary parts, combining like terms, you're going to get to a really nice place. Again, just like last time, because it's contrived, unrealistic, and fun that way. You like that kind of stuff, right? Plus 16. And on the bottom, we get r squared. Ooh, that's difference of squares. Did you see that? Right there. R plus 4 times r minus 4 is just r squared minus 4 squared. Difference of squares. And I'm writing in highlighter. Not going to use that. Okay, minus 16. So keep your radar out for difference of squares. Your squared r. Got it. And then keep combining, simplify, simplify, simplify. I think we got this. R squared plus 16 over r squared minus 16 equal to, what was the other side? Hey, it's the same thing. That's weird. I just got the same thing, top and bottom. Did you know what that means? The solving and you get the same on both sides. Do you remember this scenario? What if I put in 2 for r? Would they be the same? Would that work? 3? Negative 8? 15? Pi? Yeah. Any r I put in there, they're the same. So when it's this asking you what is the solution, it says what r's work. Well, this one is r is a member of, that's the fancy within